Okay, so this is part 2 of the review. This is on page 2 of your review. We're starting off with scientific notation. First part is we have standard notation. Okay? So, in order to get out of scientific notation, what you're going to do, somewhere different. So tomorrow, on your test, whenever you take it, you are going to have a sheet of scratch paper to work on. Basically, what I want you to do, copy the problem, copy the number that's before the times 10, so that's 99999. I want you to copy that down somewhere separate, not in the blank, because there's a reason why. Then what you do, you take your number, which in this case is a 6, I believe, and so you're going to move it from your decimal place right here to 1, 2, 3, 4, 5, 6. So, you're going to move it. Now, if your number is positive, you're going to move your decimal to the right. If your number is negative, you're going to move it to the left. Wherever there's empty spaces, you fill those in with zeros. So in this case, my number, 9999900. Now, quick check to make sure you did it right. Do your sig figs match up? Over here I have 5 sig figs. Over here I have 5 sig figs. That means that my numbers match up. I'm not going to put a decimal there unless I absolutely positively need it. Okay? So let's look at number 2. This time I have a -3. Yes, it's supposed to be a negative. It just screwed up. We forgot to put that part as a superscript. So write my number, 1.232, without the decimal. Now, because I see a negative, I'm going to move my decimal to the left. So 1, 2, 3. So 0, 0. And I put my decimal there. Okay? So I put 0.001232. And that's it. Now, with these, you need to make sure you put a 0 out in front of your decimal. So that way I make absolutely sure that it's supposed to be like that. Did I do it right or did I screw up? Did I screw up? Okay, just make sure. If I get blank looks like that and people check my math, I want to make sure I did it right. Oh, by the way, on the last problem, on the last page, number 9, it should be 1.02. That was my fault. So, instead of 1.03. Alright, so let's look at this guy right here. Then again, this is times 2, times 10 to the second.
Wait, I'm still at 9.
On the last page.
On number 9 what?
This one right here, on math operations, should have been 1.02 times 10 to the negative 4th. Like I said, that was my bad. Okay, so 1, 2, 4, 5, 4. So my decimal place was right here. I'm going to move it back 1, 2. I don't need to put any zeros in there. So it's 124.54. And that's it. Alright, so I look at number 4 right here. 9.232 times 10 to the negative 4th. So I write it out. 9232. I move my decimal to the left this time, so I see a negative. 1, 2, 3, 4. 0.000 that. So 0.0009232, excuse me. Now, notice what I did not do. I did not put this as my final answer. I want your final answer to be somewhat nice and easy to read. Now, for these guys, right here, what I'm going to do, I'm going to do one of these because of time. So I want to look at this one right here. Okay, we're going to do number 2. So this is what I end up doing. I move my existent or non-existent decimal place to the left if it's a positive number or a number greater than 1. So I'm going to do 1, 2, 3, 4, 5. I remember that number. I write times 10 to the 5th. Now the reason why I move it all the way up here is I need a number between 1 and 9.99999 ... It cannot be 10 and it cannot be less than 1. If you do, I'll mark your, well, okay, if you do, your problem will be counted wrong because it's going to be multiple choice. So then, all I write up here is my significant figures. Because I had no decimal, these zeros are not significant. So it's 1.893 times 10 to the 5th. And that's it.
Okay,
so up here, how many sig figs do I have for number 1? 1. Because I have no decimal here. Okay? So that's it. I only put 1 times 10 to the something. Okay? Now let's look at number 4. All right, for this guy, since it's to the right this time, I'm going to put a negative number whenever I count this up. So 1, 2, 3, 4, 5, 6. So it's going to be times 10 to the negative 6th. And it's going to be 4.34 because these guys up front are called what class? Leading zeros. Very good. All right, so let's look at the next page. Again, if you don't get it, copy it down, pause the video, and go back. All right, so length of the box. Whenever you are estimating or whenever you're measuring something, you always add a digit of uncertainty. Okay, you always add a digit of uncertainty. So this right here looks like it should be 4.5, and then we add in one extra digit. If it looks like it's closer to 6 than it is to 5, then it's 4.55. But in this case, it looks like it's right on the money for 4.5. So say 4.50 centimeters. Cool? All right. Same thing here. What is the volume of the substance? You look at the marks. It's marked by 1 milliliter increments. So I'm going to have 2 digits, a decimal, and then 1 digit of uncertainty. So right here, 60, 1, 2, 3, 4, 5. It looks like it's on the line for 65. So it'd be 65.0. Now I'm not going to do anything as tricky as 65.5, 65.0. I'm not going to do that. What I may end up doing is saying, hey, is this 65 or 65.0? You're going to have to be able to tell the difference between the two of them. Okay? You need to put an extra digit of uncertainty. All right, let's look over here at these guys. What would you measure with the following scientific tools? Would you measure anything with a beaker?
No.
So you put nothing. This is used for holding stuff. What is a graduated cylinder used for? Volume. What's a balance used for? What's a ruler used for? Length or distance. But with that, I really don't want you measuring distance because you're going to be out there a long time. All right, let's look at scientific questions. How long is the average cattail? Is that a scientific question? Yes. Okay? Because you can sit there and take measurements. Do fertilizers help lawns? Is that a scientific question? No. What does help mean? What do you mean by help? Does it help it grow? Does it help it look greener? Does it help it do this? Does it help it do that? That's a vague question. So I'm going to say that the answer to this one is not scientific. What about this one? How many apples taste good? Is that a scientific question? No. How pretty are the flowers? Scientific? No. How tall is the average student? Scientific?
No.
Yes, because I can sit there and take measurements.
Yeah, but what if it's like 2 from first grade or 2 from 12th grade?
Then I can find the average of those students. Yeah, that's in the question of data sets because you just figured out what I wanted you to figure out. So we asked the question, in case you couldn't hear it, of what about if you take a student from first grade and a student from 12th grade? Well, you might want to take the height of an average student at particular ages or comparing them developmentally, stuff like that. So that is a question that you can answer scientifically because you look at your data sets. All right, join me for part 3, which is the last page coming up here in a few seconds.